Hello and welcome back. We are now going to be doing a different book using trigonometry. This is the first of the lessons out of the Prerequisites chapter, so that's going to be basically the foundation you need to continue on with trigonometry. So some of this will be review and some of it will be new. So this is going to be section 1 of that chapter out of 8. So as you see, this is going to be looking at real numbers. So it's going to include the different types of numbers, number line, absolute value, and the properties of numbers. So if we look at this, I've given you a list here of the different kinds of numbers. The book begins with calling them real numbers because, as you will see at some point in the future here, we have imaginary numbers, I. So that's not going to be talking about that. This is talking about within the real numbers, what do we have? Natural numbers is something that is going to occur naturally in nature. So numbers that you would come across. So that's going to be whole numbers and positive numbers. So those are going to be natural numbers, whole and positive. And 0 can occur naturally all the time. If you don't have anything, you have 0 of it. So that's going to be included in that section as well. Integers. Integers are going to be whole numbers. They can be positive or negative, and they also include 0. Rational numbers we've spoken about recently. Those again are going to be numbers that you can write in the form A over B, where B is not 0, or A is not 0. So they can be written as a fraction. Irrational numbers that are going to be the opposite of that. An irrational number cannot be written in the form of a fraction, or I think as the book says, as a ratio, because a fraction is just another way of writing two numbers as a ratio. Non-negative numbers. A non-negative number is going to be 0 in all the positive numbers. And then the origin, that's going to come up as we look at number lines. The origin is always 0. So that's going to make a lot of sense in that respect. So the book spends quite a bit more time on that, but essentially just knowing and being able to identify out of a list which numbers fall into which of those categories. So as you can see, there's overlap between them. So you just have to know, and they'll say, list these out. So there can be times that they'll be listed multiple times, the numbers. So after that, there is a ordering real numbers is the next section. So we've done that with the IGCSE material. I mean, it's typing it in on the calculator. It's saying which is the smallest, which is the biggest. The difference now is they're going to have you put it on a number line and use inequalities. So there's going to be, it's been probably a while since you've had to do any kind of number line. The way that you can do a number line is going to be bounded or unbounded. So unbounded means it will just continue on forever. Bounded means it has to fall within specific values. So the way that you will know this is going to be given by the less than or equal to, or less than or equal, less than or greater than. So those are all going to be written differently. And if there is a value on both sides, if it's between this and between this, it will be bounded. If it's only x is greater than 2, it's unbounded on the one side. It just keeps going and going and going. Anything above 2 would fall within that inequality. So as we look at this, so if you have closed, a closed number line value will look like this. So this would mean you would have A is greater than or equal to X, we'll say, is greater than or equal to B. So when we do this, because we have this or equal to, it's going to have a square bracket, closed, closed. So it can't be less than this, it can't be more than this, and it will include these values. So let's say if this was 0, 1, 2, we'll say this is 3, -1, -2, we'll just call that a big -3. Then this would be -3 is greater than or equal to x, which is less than or equal to 3. This is what that would look like, and it's closed because the bounding of it's closed because it's on both sides it's going to include it, and it's going to be within those boundaries. So it's going to be bounded. You can also have the opposite of that, which would be open. So the closed includes the number, the open does not. So if we took the same inequality, A is, this time let's say greater than X is less than B, and we'll use these, it's going to look like this. It's open. So we can have something that looks like this if we put in 0 again and call it 1, 2, 3, -1, -2, -3. This would be -3 is greater than, we'll just say X is less than 3. So it's not included, so it's open, because it doesn't include that. And you may have seen these when you've done these in the past. But if you have a number 1, 2, 3. In the past, sometimes you've seen this as like a circle. So if we were drawing this one, it would, the open one would have an open circle, and it would be between these two values. Well, if you were doing a closed, where it included these two values, the closed had a filled in circle. So you may have seen it like written like this in the past. Open meaning open, not including those numbers. Closed meaning filled in, does include those values. You also have half open values. Well, if you had, let's say, -3 is less than, X is less than, I can't even speak, -3 is greater than X is less than 3, then all of a sudden this one on 3 would then become a square bracket, a closed bracket. So this would be half open. And the same would be true if on the other side it included -3 and didn't include 3. So you can have closed where it includes the values, open where it doesn't include the values, and then half open where it would include one of the values. It doesn't matter which one, it'd still be considered half open. So those would be the end points that it's referring to. You can also have half open that doesn't have a restriction. It won't give you the two values. So for instance, and it will go on to essentially infinity and negative infinity. So if you were given the X is greater than A. In this case, we only have one value that they're giving us, A. So this is our number line, and we know it's including it. It's going to be a closed bracket. This is going to be A. It's going to just go on. Difficult to see with this, but it will go on forever because we don't know. It doesn't give you an end point to it. And this would also be half open because only one of the sides is included in it. We don't have another point. If this were X is just greater than A, and we had it like this, forever, it would be considered open because it doesn't include that value, and we don't know what is coming on the other side, so it wouldn't include that either. The way that the notation that they would give you if they wanted you to draw this would be, if they didn't give you X is greater than A, it would be A, comma, and then this is, so I'm not very good at drawing infinity. It begins at A and goes on to infinity. If you had, if it was going the other way, if we had X is less than or equal to A, and you had a number line and say this is A, and it was going in this direction, then this would be negative infinity A. Sorry. A to negative infinity. No, that's right. So, because you want to always put the one on the left and then the one where it goes to the right. So negative infinity to A. So this little sign is kind of like a sideways 8. Again, mine are not very beautiful. Is going to show you what the infinity, if it's not doesn't have an opening, it will go all the way there. And again, it could be with a closed or an open bracket there. So that's the deal with showing the values on the number line. And then the next thing, well, actually, before we go on with that, it brings you to basically the law of trichotomy is going to say that the relationship between A and B, any two values, is they can either be equal, the A can be less than B. This would also include less than or equal to, which would be what that is. And A is greater than B. Of course, A and B, in this case, it could be any values. It's just going to show the relationship between numbers. So again, this is the law of trichotomy. Tri meaning 3. So the 3 options of the relationship between the values. With absolute value, again, this has just come up by name alone up until this point because we have looked at the matrices and to find the determinant of the matrices. They use the same symbol as absolute value. Again, this shouldn't be confusing because it should all be in context, which one you should be doing, and they'll say use absolute value in this instance as well, so that should be extremely obvious to you. But as you look at this, the properties of absolute value, so absolute value is going to always be a positive number. So that's these signs, or the absolute value signs. The absolute value of A is always going to be greater than or equal to 0. So this negative A, notice the negative is within the absolute value signs, is equal to the positive A. A times B within the absolute value signs is equal to the absolute value of A times the absolute value of B. And A over B within absolute value signs is equal to the absolute value of A over the absolute value of B. This probably makes little sense without any actual values to it and reasoning of why we would use it. This is used often to find the distance between values. So if we look at this, we can, we'll just jump to actually a question involving this to make it a little bit more obvious. So I'm looking at the exercises on page 10, and we'll go back and look at them in a second as well to go through the numbers and all that kind of stuff. If we look at, say, question 62, which is on page 11, it says use absolute value notation to describe the situation. So the distance between x and negative 10 is at least 6. Now we know distances have to be positive. We can't have a negative distance. So when we're looking at it, it says that the distance between them, so we can say x plus 10, because it's a negative, we can't have the negative there, has to be at least 6. So it has to be greater than or equal to 6. If we look at another example, then 64, while traveling you pass milepost 103, then milepost 86. How far do you travel during that time period? So it has to be positive. So 103 minus 86, we want to know the difference between it. Now this one seems like it's kind of dumb because if you were traveling from 103 to 86 and you subtract them, it's going to be positive anyway. But if you were going from 86 to 103, you could also continue to subtract it. You'd get a negative value, but again, it can't be a negative distance. So you know the answer has to be a positive 17. So either way they ask that question, it would have to be subtracting the two and the positive answer, even if it is negative ultimately. So again, this will make a little bit more sense as you're looking through the questions, and in context of it. If we go on to the next section, is the basic rules of algebra. I don't believe up until this point, although you've been working within algebra, we haven't called things by their properties. So this isn't anything new to do, it's just knowing why you can do some things or why certain things in math are true. So on page 7, there is a list of all of these basic rules of algebra, and you can see listed on the page there is a commutative property, a associative property, distributive property, and identity properties for addition and subtraction, and then you have multiplication as well in that section. So some of these are just talking about why it's true. And so if you look in the book there, it will be important for you to know and be able to identify which one is which. So if you want to look, it's the associative and then the inverse property as well. So make sure that you look at that list and are able to identify certain things on there. And I'll go over one to kind of show you. On page 12, if we look at question 88, it gives you 2 times 1/2, and it asks you in this section, identify the rules of algebra illustrated by the equation. So in this case, this is going to be the multiplicative inverse, because you're multiplying by the reciprocal. Again, this is just illustrating what was already given to you. On 90, they say x plus 3 minus x plus 3 equals 0. This is called the additive inverse. So if we subtract the 2, it equals 0. It's not that these are overly complicated, it's just the naming what it actually is. If you look at question 92, it says z minus 2 plus 0 equals z minus 2. Again, this seems pretty obvious. This is illustrating the additive identity. You can remember with the matrix identity, it always included zeros. That will be the same thing with these kinds of identities. They'll include zeros. If you look at question 94 in the book, it's basically the parentheses are just changing places in that one, and that's going to be the associative property of addition. So again, if you can just look through at that list, I know it seems kind of gets a lot of thinking, but once you understand the property behind it, it will be important in helping you to be able to justify why something is true and why you can do something. So that's this lesson. I'm going to have you guys now look at the questions in these exercises on the page 11 and 12, and go through some of these on and make sure you understand. All right, go ahead and go at it.